Welcome to This Explainer. Look, today we're diving into something that literally every data architect and developer struggles with: cross-team knowledge sharing. You know the headache, right? Trying to force every single department to use the exact same terminology just to get your systems to talk to each other. Well, what if we didn't have to do that? What if you could achieve perfect interoperability, but let every team speak their own native language? That's exactly what we're unpacking today with a fascinating new data model. Let's start with a really provocative question, one that hits right at the core of AI news right now. If AI generates knowledge so incredibly fast, why is sharing it across teams still so completely broken? It's a massive pain point. Sure, AI can blast out a comprehensive report in seconds, but the second you try to actually integrate the structured findings from that report into a different system, say moving data from a research silo over to engineering, everything just grinds to a halt. The generation side of knowledge is lightning fast, but the transmission side, it's totally stuck in the past. So, here's our roadmap for the explainer today. We'll look at why current document systems fail, the semantic convergence trap, what the MMM model actually is, how it decouples structure from semantics, and we'll wrap up with a practical developer implementation guide. Okay, moving right into section 1, why document systems fail. We basically have two main approaches to storing knowledge right now. And honestly, both are failing us at scale. On one side, we have traditional documents. Think of these like a beautiful, continuous painted mural. They're meant for linear consumption, great for reading a finished thought, but the minute you need to extract just one specific data point, it's like trying to chisel a single brushstroke out of that mural without destroying the whole thing. Then, on the other side, we have formal approaches, like RDF graphs or really strict schemas. If traditional docs are a mural, these formal schemas are like rigid steel scaffolding. They definitely fix the structural fragmentation, but the adoption friction is just astronomical. Contributors end up abandoning them because the overhead of perfectly modeling data to fit that rigid structure completely outweighs the benefits. And this brings us to exactly where we are today in the AI era. AI has absolutely accelerated document generation. It's flooding us with more text than ever before. But here's the catch. AI doesn't magically replace the underlying exchange format. It literally just makes the pile of traditional documents taller. Both humans and AI agents still desperately need a portable, structured medium, something machines can easily parse, but without needing some massive central committee dictating how everyone has to speak. Which brings us to section 2, the semantic convergence trap.
This right here is the fatal flaw of so many formal systems: semantic convergence. By definition, this is the requirement that all participating systems, disciplines, or organizations have to agree on a shared ontology or a strictly controlled vocabulary, basically demanding that an engineer, a biologist, and a project manager all use the exact same words to describe their data. I mean, good luck with that, right? It's an incredibly heavy coordination problem that scales horribly. It essentially forces humans to act like perfectly synchronized machines, and it's exactly why so many enterprise knowledge graphs end up failing in the real world.
All right, section 3. What is the MMM model? Let's look at the solution. Enter the data model, introduced in a really brilliant research paper on Archive by Mathilde Nuel. stands as a normative specification for decentralizable knowledge commons. What that means is it emerged directly from the messy, practical needs of interdisciplinary research. It's designed to step in and either replace or augment those broken document-centric architectures we just talked about. It's not an app, it's a decentralized spec that lets highly diverse systems seamlessly talk to one another. Here's how it works. MMM defines a really compact set of normative structural constraints. But, and this is the absolute genius part, it pairs those strict constraints with free text labels. Think of MMM units exactly like Lego blocks. The bottom of a Lego block has those very specific interlocking plastic tubes and studs, right? Those are the structural constraints that dictate how pieces physically connect. But the outside of the block, you can paint it any color or slap any label on it you want. MMM preserves that domain-specific terminology. Your team can call a block whatever makes sense to them, and the whole thing operates without any central registry policing your vocabulary. Let's hit section 4, decoupling structure from semantics. This is where it gets really good. Let's look at this magic in action. Say we have System A, maybe a team of data scientists, and they label a specific node as research phase. Over in System B, the product management team labels their node milestone. In a traditional setup, these two systems have no idea they are talking about the same thing without building a custom translation layer. But look at the MMM constraint. Because both systems use the MMM data model, the structural metadata underneath is what governs the relationship. The system recognizes that structurally, these nodes are behaving in the exact same way. It treats them as equivalent based on that structural relationship, totally ignoring the actual string of text.
The crucial takeaway here is this: structural integrity is greater than lexical uniformity. By decoupling the structure of the data from the specific vocabulary words used to describe it, entirely heterogeneous systems can exchange knowledge units without a hitch. You literally never have to rewrite your internal taxonomies to match another department's. You just enforce the structural invariance. Humans get to keep their messy, flexible native words, and machines get the rigorous boundaries they need to assemble knowledge at a massive scale.
Finally, Section 5, Developer Implementation Guide. Let's make this actionable.
If you're building AI research assistants or maintaining a knowledge platform, here's how you put this into practice. The beauty of MM is that it's built for incremental integration. No need to rip and replace your whole stack today. Here are your 4 tactical priorities. First, enforce constraints at ingestion. Validate those structural rules the second data enters your system, but let the free text labels pass through completely unchanged. Second, design export pipelines specifically for format translation. Third, track deterministic version lineage. And fourth, validate against pilot deployment data. A great starting point is simply wrapping your current document parsers in a constraint validation layer.
Drilling down into those pipelines for a second, it's absolutely critical that you map MMM structures to your target formats, things like Markdown or JSON-LD, while rigorously preserving the constraint metadata during the export. Another huge thing, avoid softlinks at all costs. In distributed knowledge assembly, softlinks will absolutely break the second a source node shifts or merges. Instead, rely on deterministic reference resolution so your network stays rock solid. Oh, and the researchers actually provided a reference implementation. Definitely use that for your interoperability tests to see how your system handles edge cases like constraint violations. To sum up this entire paradigm shift, it boils down to this quote: build interoperable systems by focusing on structural invariance rather than lexical agreement. We have to stop trying to force humans to agree on words. It's an impossible task. Instead, let's just enforce how the data behaves structurally, because machines are already incredibly good at managing that.
So as you look at your own data architectures and AI workflows, I want to leave you with this. How will you implement structural invariance in your system? Are you going to keep forcing everyone to use the same dictionary? Or are you ready for a model that finally prioritizes structure over semantics? I highly encourage you to check out the full specification on arXiv, paper 2607.0032, and see how you can start enabling frictionless cross-team knowledge assembly today. Thanks for joining me for this explainer, and we'll catch you next time.